Thank you. My name is Hudson Worsley from Precinct, and I have the great pleasure of being the chair of MECLA and the MC for today's event. Before going any further, in the spirit of reconciliation, I would like to acknowledge the traditional custodians of country throughout Australia and their connections to land, sea and community. We're meeting today on Aboriginal land around Australia, and I pay my respect to elders past and present and extend that respect to all Aboriginal and Torres Strait Islander peoples participating today. I'd like to make some points about the mechanics for today's session. We are recording the event for future use, future viewing. The event is being viewed by over 450 registered attendees. So that's a record for us and a mark of the interest in embodied carbon and particularly in design. Please keep your microphone muted, as I mentioned, and feel free to use the chat function for comments and questions. We'll be fielding these throughout the event. A quick governance reminder. I know I say this at the beginning of every event, but MECLA does not tolerate any anti-competitive behaviour. We operate deliberately in a pre-competition environment. We're also acutely aware of conflicts of interest. So if you are aware of a conflict, please speak up and we can ensure we adjust accordingly. So, the collaboration of our organisations, MECLA, we come together to drive reductions in embodied carbon in the building and construction industry. This is the critical decade for action, to bring greenhouse gas emissions into a trajectory consistent with meeting the Paris Agreement to limit global warming to 1.5 degrees Celsius. We know this is hard. It isn't easy, and none of our organisations can achieve this alone. And alone, nobody can take the risk of stepping forward without the construction ecosystem moving with them. So we are moving together. Industry, government, professions and researchers, arm in arm towards a common compass bearing. Something our friend Monica Richter calls radical collaboration. MECLA is a do tank. I love saying that. MECLA is a do tank. That means we're all about action. We're sharing knowledge, for instance, today across the construction ecosystem to overcome barriers that slow down the take-up of low emission materials. And today, that discussion involves some amazing speakers. I'm going to go through the bios just so that you have a gauge of who we're listening to before I hand over to Ross Donaldson, who will facilitate the discussion. Firstly, to Ross. Ross is an architect. He's the founder of EPM Experimental. He's the chairman of Bridge 42, the Australian Institute of Architects Climate Action and Sustainability Task Force. He's the former CEO and chairman of Woods Bagot, and he's an adjunct professor at the University of Western Australia. Our first speaker will be Lucy Marsland, an environmental designer at Atelier Ten. Lucy is a structural and civil engineer. She's a passionate advocate for sustainable, resilient and environmentally sensitive buildings that empower and connect occupants and their communities. Lucy leads Atelier Ten's material and embodied carbon practice as a certified Green Star accredited professional, or GSAP, and she's a member of MECLA. Daryl Stuckey is the head of sustainability transformation environment at Lendlease, has been a big contributor to MECLA. He's an environmental scientist with over 20 years experience in sustainability across corporate, consulting and regulatory settings. In his current role within the group sustainability function, he's responsible for Lendlease's global decarbonisation, climate risk and environment strategy. During his time at Lendlease, Daryl's been instrumental in developing the business's in-house life cycle assessment capability. He's been responsible for managing, collaborating with project teams and supply chain partners to deliver Lendlease's embodied carbon reduction commitment for the Barangaroo South Waterfront Urban Renewal Project, not far from me here in Sydney. Bridget Dank is a structural engineer in the building structures team at Arup. Bridget applies her design and technical skills on various projects and digital initiatives, including data centres, the Melbourne Metro, a level crossing removal project and other buildings. She's got a strong interest in realising more sustainable design on projects to minimise the impact of our industry on the environment, and she works within Arup as well as collaborating with others in the industry. Bridget holds a Masters of Civil Engineering at the Technical University of Delft in the Netherlands, majoring in structural engineering. Christopher Royal joins us from Transport for New South Wales, where he's the Director of Sustainability. An internationally experienced environment and sustainability director, he has over 20 years professional experience in environment, planning, sustainability, energy, climate change, and renewable energy. And from overseas, we're joined by Will Arnold from Greater London in the UK, Head of Climate Action at Institution of Structural Engineers. He's a structural engineer focusing on the decarbonisation of the construction industry, passionate about helping the profession to maximise its positive impact on people, places, and the planet. Prior to his current role, he was a practicing engineer at Arup for over 10 years on projects around the world. He sits on the institution's Climate Emergency Task Group, the Engineering Advisory Group for the Structural Engineer Journal, and is a judge for the Structural Awards. He sits on several other steering groups and bodies, so we'll look forward to hearing from him throughout today's conversation. So these are our contributors today to today's discussion. Ross Donaldson, I now pass the baton to you to take a lead on the conversation. Thank you, Ross.
Thanks a lot, Hudson. Well, I have to say I can't wait for this. It's such an important topic and some great material I think we're going to be going through. And I think we'll repeatedly hear that in this sphere, we have to set ourselves up for success from the very beginning, hence pre-design strategies. So Lucy's going to introduce the basics of life cycle assessment and the importance of measuring. And then Daryl's going to take us through the terrific case study of managing supply chain, the Barangaroo project. And obviously Len Lease has been leading in this space for a long time, as has Bridget's firm Arup, been a terrific leader in showing the way. And Bridget's going to be focusing on structural solutions and how important that is in getting the base reductions right. And then Chris is joining us from Infrastructure New South Wales, because obviously it's not just about buildings, although those of us in buildings sometimes get caught up and think it's all just about buildings, but of course there's much more to it than that. And Chris has got some really interesting material in terms of the framework for getting it right and setting up the processes and decision making. And Will has very kindly agreed to join us to give us a bit of a UK perspective on all of these topics. So I'm going to be diverting to Will in between each speakers to get his response and take on what's been said and perhaps some expansion. One of the things that Will didn't put in his profile is that he's one of the prime movers of the so-called Part Z addition to the planned UK building regulations that will mandate measuring of carbon for all buildings above a certain threshold. And I forget whether it's 1,000 square metres or what it is, but Will might tell us. All right then, Lucy, get us going. Over to you.
Thank you so much, Ross. I'll share up my screen and get us moving along. Hopefully everyone can see that now and can hear me well. So my name is Lucy Marsland. I'd first like to reiterate Hudson's sentiment and acknowledge the country that I'm coming from. It's the Wurundjeri Woiwurrung people of the Kulin Nation down at the bottom of Victoria. I'm an LCA practitioner, and today I'm going to lay some foundations of what LCA and embodied carbon is and introduce some of the challenges and opportunities of being a practitioner. So why we're all here today is this industry pursuit of net zero. It's beyond our built environment industry, but really the whole world is pursuing net zero. But I think sometimes one of the challenges is bridging the gap from what net zero looks like and how we actually get there. In the past, it's all been about operational carbon, the energy grid decarbonising, but now the talk of the town is this embodied carbon. So we'll just get through what that looks like and how we're going to measure it. So embodied carbon comes down to a project, whether it's a building or an infrastructure project. We're looking at the global warming potential or the embodied carbon of the materials or the resources being used in the life of the building. I'm an engineer, so I'll always bring it back to metrics. We're talking kilograms of carbon dioxide equivalent per functional unit. So whether that's a building per meter squared of gross floor area or per meter cubed of concrete being poured, we're always talking about kilograms of carbon dioxide equivalent, where all greenhouse gases are accounted for and then converted back into carbon dioxide as a common language for us all in industry. So when we say embodied carbon, we mean global warming potential, and those two can be interchanged as we talk sort of informally, but technically we'll always use this GWP. This is our pathway to reduce our embodied carbon towards this net zero that we're all trying to pursue. And luckily we've got international standards governing this process, the ISO standards and the EN standards governing the data and starting to govern the methodology that we approach LCAs and embodied carbon with more generally. I think the challenge and what the spotlight is really all about is how to deal with embodied carbon before we have the information to undertake a full life cycle analysis. So while our standards govern this detailed documentation phase, the early pre-design is where the data needs to be interrogated and really good rules of thumb need to be used by the whole design team, not just LCA practitioners. So these talked about these standards. What does this really look like? This is our rainbow of life cycle analysis. We use these, you'll hear in all the talks talking about A1 to A3, A1 to A5. This is our upfront embodied carbon and where the majority of carbon emissions live for a building. We can then conversely look at embodied carbon more broadly, so including the full material life cycle of a building, excluding the operational carbon associated with the water and energy being used. And finally, we can look at a whole of life carbon, capturing everything within the building, scope 1, 2, and 3. It's often missed out, but the scope D, beyond the boundary, recovery, reuse, and recycling, a critical opportunity for our industry and something that needs to be targeted early in design because it is something that needs to be built into the fabric and the systems of a building or a piece of infrastructure. We do not include it in quantifying an LCA for documentation purposes due to accounting nuances. Now, we know our scope, but how does it all come together? Life cycle analysis, this beautiful rainbow wheel, is really a simple accounting exercise. A times B, material quantities times the environmental profile of each material within the building. So as you can imagine, material quantities, we need a specific detailed design, and there lays a challenge of an LCA practitioner is timing the balance of doing a life cycle analysis with having the information available. And for that reason, pre-design is often about, as I said, good principles, interrogating the data in the supply chain and working in an integrated way with the full design team in order to get good outcomes before we can undertake the documentation of an LCA with that detailed design. So once we've got our numbers, we can start to reduce, and as I'm saying, sometimes we're reducing before we have the numbers. So this is our classic hierarchy, upside down triangle, where we first say use less stuff. So simple, use less stuff. It's really important to understand, as we do with energy, we want to reduce before we look to sources. So we want to use less stuff before we specify, and definitely before we look to offset. That is a critical chain of priorities for embodied carbon design. What does use less stuff look like? It should always start with build nothing. Do we need this at a planning level, looking at adaptive reuse, looking at existing assets, extending the service life of existing buildings. And then we can look to build less, really smart architecture, flexible spaces, multi-function buildings. That's the second step of really reducing as an industry. We can then get to some nice engineering, more comfortable moves, building clever, building efficiently, making our materials work really hard, fully utilizing our systems. And finally, getting to construction and building out waste, working with contractors and maximizing their expertise to have a really efficient on-site construction and reducing those emissions. Then we may come to specifying low carbon products, engaging with our supply chain, and finally offsetting any residual emissions. At the moment in Australia, we take a percentage reduction approach to benchmarking LCAs, and here lies another challenge, but also an opportunity. I'm using the beautiful fulcrum design at Green Square in Sydney, designed by Bates Smart, that I'm currently working on, so I can't share any outcomes, but I can discuss the process. So we take our DA design submitted to council, quantify it and set 100% as the benchmark. Then through an integrated design process, the design team can get to a proposed model and with an associated LCA, and in this way demonstrate a percentage reduction. I'm hoping that Will and other presenters can discuss what the future may look like and how we move from percentage reduction from a business as usual, which comes with its challenges of definition, moving to a budget benchmark approach akin to the EU levels system. So the last way is sort of describing a bit more in detail what this iterative process towards a reduction looks like. So this is probably a bit of a classic integrated design graph that we've seen before, but I've changed it up a bit. So we look as over time on a project, we lose opportunity to influence the design and costs increase. So rather than peaking in the center, we really want to, as LCA practitioners, move beyond documentation and analysis and move towards design facilitation in an integrated way. Build less, build clever before we get to detailed design, build out waste and specify materials as the design develops. And by the time we get to construction, we have slowly reduced the embodied carbon and improved the design incrementally rather than in one significant peak at the end of design. So that's what I bring, the opportunities and the challenges. We really want to see the industry working together to firm up our benchmarking, to create a rigorous and transparent methodology for all to share, and to continue to collaborate between LCA practitioners, but also within interdisciplinary design teams. Embodied carbon is not something that can be resolved by a single practitioner. It is something that is owned by a project, and in that way we can get to a architecture, engineering and construction community or ecosystem that is driving embodied carbon innovation on a global scale. So I think there's a real opportunity there. Thank you so much. That's all I've got, and I'll pass back to Ross.
Thanks very much, Lucy. Very clear and succinct. Thank you. That was terrific. Boy, you touched on a few things that prompt potential questions, but one that I would like to see if Will can kind of bring us in on. You touched on the end there about benchmarks, and you talked about data a number of times during the course of it and standards and so forth. And Will, I'm just wondering, with your work around Part Z and planning to mandate reporting and then stepping towards benchmark performances over the coming years in the UK, can you talk a bit about the challenges of getting agreement around the data? Because in this country, there's a lot of debate around the veracity of the data and variations in the outputs of reporting from LCA processes. But if you got to the point of going for Part Z and mandating it, you must have got to a comfort level in the UK that the data's convincing and the methodology is good. Would you like to add some thoughts on that?
Yeah, sure. Hi everyone, and thanks Lucy for a great presentation. So just to mention what Part Z is first, it's something that's been proposed by industry rather than by government. So in effect, this is the UK construction industry saying to our government, look, we want to see embodied carbon regulated in this country, please. We think it would be to the greater benefit And there's all sorts of supports on there, and I'll put a link in the chat for anyone who's not heard of it before. But yeah, if when we get to the point where embodied carbon is regulated here, because it's definitely a case of when rather than if, you're right, there would need to be agreements on carbon factors that are used. So when you multiply your quantity of materials by a factor to work out the total amount of carbon due to using that material, if somebody else thinks that factor is different to what you think it is, you get a different total number, and that can be a problem if you're trying to meet targets and benchmarks. So the proposed way of doing this is that prior to starting construction, everyone uses a set of factors that's been pre-agreed in advance that are based on a sort of, for us, a UK average or a UK typical for each type of material. And we've already gone quite some way towards working those out for different structural materials as part of the research that went into our guide that we published at the start of this year, how to calculate embodied carbon. So we looked at what types of steel get consumed in the UK and therefore what typical steel looks like. But then, of course, once you then complete construction, you should be able to update lots of that data based on the as-built information, which would include your EPDs for your materials that you use, which I'm sure somebody will explain what EPDs are as we go forward. So yeah, I'd say we're at the point where for a lot of materials, we've done the research to say what we think the sort of typical or the generic factors should be that you would use. We're probably not quite there yet on all of them, but we're within the level of confidence now where if the government was to say we're going to enact Part Z within 6 months or a year, that those other values could be sort of sorted out and pulled together.
And just quickly, I was very interested in the Royal Institute of Chartered Surveyors professional statement that sits alongside Part Z, which kind of informs the methodology of interpretation of the standards and so forth. And can you say just a brief bit about how that helps with the veracity of the outcomes?
Yeah, sure. So the mixed professional statement, which is kind of the de facto standard on this in the UK, it's actually been out now for 5 years and they're updating it at the moment. So the second edition is due to come out in, I think, start of next year, which is quite exciting. That document effectively takes those ENs and ISOs that Lucy showed and sort of translates them into a guidance document. So it's written a bit more in plain English about what you must and mustn't do. And it's because it's become the sort of go-to document on this, it means that there is a certain level of consistency that gets brought about by that you wouldn't have if it didn't exist. And actually the work that's happening at the moment is to bring further consistency to it. So there's still some areas that it doesn't really touch on, such as the scope of your calculation, that they're trying to sort of hone in on over the next few months whilst they update that. So yeah, it's a really good document. If anyone's interested in life cycle analysis and they haven't seen it before, do look it up.